First off, I have a misprint here, so apologize. I know you're shocked here. And so in 2000, the population of Africa was 807 million. In 2011, it had grown to 1,052 million. Find an exponential growth model that models the data from 2000 to 2011. Okay, so this is a growth model. So we could do A equals A naught times e to the kt. Okay, k is going to be our rate, and then t is the time. So to find the model, what we have to do first is we have to solve for k. Okay, so we're going to start with our 2000 year. Okay, that's going to be our initial year. We're going to start with the 2000 year. And so in 2000, the initial amount was 807. Okay, so our initial amount is 807. All right, E, K we're solving for. Now, from 2000 to 2011 is how many years? T would equal 2011 minus 2000, so T would equal 11. Now, what this will be, the A naught, I'm gonna write this down. A naught is 807 because that's the initial amount. That's the beginning here of this problem. So like in 2000 is kind of our beginning year. A is equal to 1052. So it's kind of that amount after that, your kind of your final amount from the model here. So then remember, we got to isolate the expression. We got to solve for K. So we got to solve for K because the K will give us the rate of growth. So 1052 divided by 807, and that gives you 1.304 is equal to e to the power of 11k. So how do I bring down the exponent? I take the ln of both sides. It's 11k ln of e. Okay, and then to get k by itself, divide by 11, divide by 11. So k will be ln of 1.304 divided by 11. So it'd be 0.024. So what's my model going to be now? So my model is going to be A equals my initial amount, which is 807, E to the K, which is 0.024, T. And what does T represent? T is years since 2000 because I'm starting with 2000, years since 2000. Okay, since I'm starting at 2000 for my initial value there, then I have to use that as years since 2000 for my model. By which year will the U.S. population reach, which year will the U.S., it's supposed to be Africa, well, Africa, I messed this all up, will reach 200 or 2000 million, which would be 2 billion. It's also 2 billion. So, but you're going to put 2000. So I want to know when it reaches 2000. So I'm going to use this model over here, and my A is going to be 2000. So 2000 equals 807 e to the 0.024 t. I'm going to isolate the exponential expressions. Divide by 807, divide by 807. So 2000 divided by 807, 2.478 equals e to the 0.024 t. And then I'm going to do the ln of both sides. 0.024 t, ln and e, that just cancels. Then we'll divide by 0.024 to get t by itself. So t will equal approximately, now remember this is years since 2000. So this is going to be we're going to have to do a little bit of adjusting here. So 37.81, so around 38 years since 2000. So what does that mean? Around 2038.